All right, ladies and gentlemen, if we want to graph 1/2 to the x, how would I start by doing that? You'd make a what? Table. What numbers am I going to put in that table? -2, -1, 0, 1, and 2. Okay. Don't forget, ladies and gentlemen, that when you're taking 1/2 to the -2, what's the first step? Flip it, and then what's 2 squared? Okay. If you're taking it to the -1, what's the first step we do? Flip it, and then to the 1 is just 1/2 to the 0 power is 1/2. Let's all say this. 1/2 to the 0 power is 1. Anything to the 0 power is
1.
Anything to the 0 power is
1.
Anything to the 0 power is
1.
Let's not forget that. Okay. 1/2 to the first power is what? 1/2. 1/2 squared. What's 1 times 1? What's 2 times 2? That's how we do fractions. We multiply the tops, multiply the bottoms. Write this down, advanced operator. Okay, so you have gotten partial credit so far for your problem. In order to get full credit, you must have a scale. I'm just going to go up by ones. You must have a scale for both x and y. Then we plot these points. At -2, we're at 4. -1, we're at 2. 0, I'm at 1. 1, I'm at 1/2. And 2, I'm at 1/4. You must draw a line through it. You must have arrows at the end. Question about how to graph. Okay, is this a growth problem or a decay problem? Okay. All right, it's going to disappear. And I'm going to bring up the next graph. All right. So again, ladies and gentlemen, you have to have a table. Now you could have set up, instead of a 2-place table, you could have set up a 3-place table. So you can show your work and you know where it is. Plug in -2, -1, 0, 1, and 2. So you go 3 times 2 to the -2, which we know is 3 times 1/2 squared, which I know is 3 times 1/4, or 3/4. You don't have to do all that. You can just put it in your calculator. If you don't have one and you want to do it this way, that's totally fine. Okay. 3 times 2 to the -1 is 3 times 1/2, which is 3/2, and 3/2 gives you 1 1/2. Okay. Anything to the 0 power is, so 3 times 1 gives us 3. Okay. 3 times 2 to the first power. What's 2 to the first power? 2 times 3 is? Okay, what is 2 squared? 4 times 3 gives us? I'm going to set my scale for this one. I'm going to go by, let's say, 2. Okay. Then I'm going to plot the points. At -2, I'm at 3/4. At -1, I'm at 1 1/2. At 0, I'm at 3. At 1, I'm at 6. And at 2, I'm at 12. Do you guys feel like you get the hang of graphing? I'm going to have you do the last 2 on your own then. Is this a growth or a decay problem? Growth. All right. Let's move on to the story problem to make sure you have that one. Okay. A family purchased a condo for $60,000. Each year, the value of the condo increases by 4%. Write a function that models the value of the house over time. Then find the value of the house after 5 years. Is this a growth problem decay problem. Is the house going up in price or is it decreasing in price? Up, so it's a growth problem. So I know I've got P times 1 plus R to the T. So I start with my initial amount, times that by 1 plus, what's my rate? 0.04. Make sure you're not writing 40%. You've got to have that 0 in there. And we're going to do it over 5 years. Okay? So this is when you get out your calculator. Make sure you do what's in the parentheses first. So 1.04 raised to the 5th power, and then multiply that by 60,000. And we get approximately 72,999 because it wants us to round it to the nearest dollar. Any questions about the story problem? What? Anybody else? Okay, let's turn and do those last 3. Okay, we're simply going to say whether it is growth or decay. So are these numbers getting bigger or smaller? So what is it, growth or decay? Is this graph growth or decay?